Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this third part of the video regarding application of geometry, we will discuss about angle between two straight lines. So this is the learning outcome. So we focus on the second outcome, that is the angle between two straight lines. So what is the angle between two straight lines? So you can read from this statement. Okay. So I won't discuss a detail about this one. Okay, you can read what is V1 and V2. So basically from line L1, so the vector parallel will take V1, and from line 2 the vector parallel will take V2. So remember from the scalar product, the formula to find angle cos theta. So from here we can write down AB will be V1 dot V2, and then magnitude V1, magnitude V2. And to make easier, you can straight away theta equals to inverse cos. So later in the example, we'll use straight away theta equals to inverse cos. Okay. So this we will use this straight away theta equals to inverse cos V1 dot V2 over magnitude V1, magnitude V2. Right. And don't forget, as usual, if the two straight lines are perpendicular, the dot product will be 0. Okay. So if parallel, we can relate V1 equals to constant V2 or alpha or lambda V2. Okay. If the two straight lines are parallel. And then one more thing, if the dot product is negative, so the angle that you get usually the obtuse angle, that is angle greater than 90 degree. So actually we can get the angle besides that. So we consider that one is also the angle. So just 180 minus the obtuse angle, then we can get the acute angle. Okay. So we straight away go to example 7 or example 1 in this video. So given from line 1, so line 1 it is P. So this is a equation for line 1, and then Q, the equation for line 2. So find the acute angle between two straight lines. So remember from these two, so we can find out V1 and V2 from here. Okay, as I highlighted, so this is V1, and then from line Q, so this is V2. Okay, right, next we substitute into the formula. So inverse cos V1 dot V2 over magnitude V1 magnitude V2. So the dot product. Okay, so already you can plug in your calculator straight away, and then you get the angle. So 17.975 degree, or you can run out into two decimal place, 17.98 degree. Okay, so that's for example 7. And then look at example 8. So given L1, so this is an equation for line L1, and then this equation for L line 2. So find equal angle between L1 and L2. Do highlighted about the equal angle. So maybe you will get obtuse angle in this case, so you have to find out the equal angle. Right, so first from the L1, so we get V1. So from here 2, 3, 4, and then from V2, so for V2, that is from L2. So this is Cartesian. Remember the previous video. So actually this one is over 1. So below here would be our V2. Okay, that is 1 from here, so 2, and then negative 4. Okay, and then we substitute into our equation to find the angle. So we notice that the dot product is negative. Okay, so the dot product is negative. So with that, we will get the obtuse angle. Okay, your calculator will give the answer in obtuse angle that is greater than 108, greater than 90 degree. So as I said earlier, it's actually the refers to the same angle. So you will find the angle besides that. That is, we subtract from 180 to get the acute angle. So the acute angle will be 180 minus the obtuse, that is 108.9. So we will get the acute angle, that is 71.1 degree. Okay, so that's the answer. That is the acute angle between L1 and L2. Okay, next for example 9. Find the acute angle between line and the equation. So between this line and the x-axis. Okay, so the x-axis, so we only have I, right? No J and K. So V1, of course, from here 3, -1 and 1, and then V2, since you only have I, so 1, 0, 0. Okay, so I hope you understand how we get 1, 0 here. That is because we have I only. Okay, right, next, after we got V1 and V2, so straight away we substitute into the formula. So above here we do the dot product. So remember we only have I, so that is 3. So the rest multiply with 0, we got 0 lah. So only 3 above here. And then below here, find the magnitude for V1 and V2. So we got the angle is 25.2 degree. Okay. Right. Next, example 10. Find the acute angle between the line with the equation. So this is equation for L1 and parallel to the vector. Right. So this is the situation. So let's say this is L and L1. And mention that the L2 is parallel to the vector I plus j minus 2k. So this is our vector L2. Sorry, our line L2. So this line L2 is parallel to vector this one. So it means that to get V2, we can straight away use this value. Okay. So for L1, of course, we use this. We get this from for V1. But for L2, so we use the vector parallel as our V2. So 1, 1, -2. Okay, will be our V2. Okay, next, we will substitute into the formula to get angle. So as usual, above here we do the dot product, and below here we find the magnitude. So again, when we find out the dot product is negative, it means that our angle is obtuse. Okay, so this is obtuse angle. So to get the acute angle, so remember the previous examples. So to get the acute, we will subtract from 180. So 180 minus this obtuse angle 140. So we get 39.7 degree. Okay, as our acute angle. Right. So I think that's all for this video. Very short because the angle is very simple. Just use the angle from the dot product. So don't forget, our next video we will discuss still about application. That is, this time we'll discuss about equation of a plane. So until then, thank you very much. Bye bye.